The state of Gujarat realized that for development to be sustainable, ecological and economic efficiency as the basis of future strategies in business was essential. The Department of Forests and Environment, Government of Gujarat, has spurred an initiative for promoting cleaner production as a tool for improving environment and economic performance for the small and medium enterprises or SMEs. Cleaner production is defined as the continuous application of an integrated preventive environmental strategy applied to processes, products and services to increase overall efficiency and reduce risks to humans and the environment. Cleaner production can be applied to the processes used in any industry, to products themselves and to various services provided in the society. The UNIDO National Cleaner Production Center NCPC program was established in 1994 to build local capacity to implement cleaner production in developing countries and economies in transition. The program is based on the premise that cleaner production will only be truly integrated into the country's industries and policies if local capacity is in place to sustain it. There are 43 National Cleaner Production Centers or NCPCs that have been established through bilateral, governmental and other forms of assistance. The 4 regional CP centers of India are Gujarat Cleaner Production Center, Karnataka Cleaner Production Center, West Bengal Cleaner Production Center, Punjab Cleaner Production Center. These CP centers are financially supported by the various government departments while technically supported by NCPC. A proactive step, Gujarat Cleaner Production Center GCPC has been established in GIDC in the year 1998 with technical support of NCPC and UNIDO. Gujarat Cleaner Production Center plays an important role in educating, permeating and providing knowledge as well as expertise to tackle various environmental issues that the various sectors of the industry shall need to address in the current scenario. GCPC is widely involved in conduction of various orientation programs, training programs, CP assessment, CT assessment projects, etc., which have successfully spread the message of cleaner environment in various sectors of the industry. GCPC has taken up demonstration projects in various sectors like dyes and dye intermediate, pharmaceutical, textile, dairy, ceramic, chemical and petrochemical. GCPC has also been selected as ENVIS or Environmental Information System Center of MOEF, Government of India. Though GCPC is a regional cleaner production center, UNIDO has recognized the center at par with National Cleaner Production Center by considering the center as a partner of RECP or Resource Efficient and Cleaner Production. The Department of Forests and Environment has assigned GCPC a project of CP implementation in the textile sector. The project is to create cleaner production opportunities for improving resource efficiency and preventing the release of contaminants to the air, water and land and implement some of the options. As a part of this initiative, it has decided to conduct CP implementation project by Gujarat Cleaner Production Center. One of the objectives of the GCPC is to demonstrate industry progress in the area of cleaner production and energy efficiency and to share leading edge and best practices. As per cleaner production methodology, 5 textile units were selected for the project.
Whenever we mention about industries, there is also mention about pollution, which is inevitable in industries. Well, to address this problem, we started with what we call end of pipe concept. So later on, there was a talk of preventive step, and that is what cleaner production is. The Gujarat Cleaner Production Center has a separate entity which is registered under society. Well, the major activities taken up by GCPC is to make people aware about this concept. After creating this CP assessment, we implement also so that industries can get advantage, economical benefit as well as improvement in environment. And then we arrange dissemination program. Under this same project, even our Department of Forest and Environment, state government realized, and a project was given to us, particularly this project of implementation of cleaner production tools which are already generated in our cluster of textile industries, which is very important in Gujarat. The water consumption, the energy consumption, the raw material is a huge, and there is also problem of pollution. So the GCPC started implementing, and while implementing, GCPC team, which is expert of chemical, environment engineers and environmental scientists, generated additional source. So we generated so many options, what we call simple tools like good housekeeping, process optimization, raw material optimization, possibility of recycle and reuse. Industries also have realized that it is in their benefit, they can reduce waste right at source. Also while doing so, there is economical benefit and overall improvement in environment. So these selected industries have also implemented the already CP generated tools and also additional CP tools generated by GCPC. The results are very fantastic. They have realized that that is required. We have documented that result. And also, as I told you, that we need to disseminate the result of this. So we arrange a good dissemination program wherein we don't speak anything, but the industries who have implemented, they come to the dais and then they tell their friends that what they implemented and what benefit they got. We are thankful to the Department of Forest and Environment for giving us this project, and I am very hopeful that this CD, which consists of the applicable tools and already implemented tools with the benefits, will help industry so that directly they can implement and get benefit of environment as well as economy.
5 cleaner production teams, one each for the selected unit, comprising of GCPC officials and personnel from the selected units, were selected to carry out the CP study in the units. The team members selected that all the major and representative departments of the selected units were included within. The textile industry has been one of the oldest and most important sectors of the Indian economy. It is the second largest employment provider in the country, next to agriculture. It contributes to almost 1/3 of foreign exchange earnings, contributing to 3% of the GDP. India has also been a significant player in the global textile markets. It is the 3rd largest producer of cotton, the largest producer of jute, the 2nd largest producer of silk, and the 5th largest producer of synthetic fiber or yarn. The Indian textile industry is a highly fragmented sector. Industry is fully vertically integrated across the whole value chain and interconnected with various operations. Textile industry comprises small-scale, medium-scale, large-scale, non-integrated spinning, weaving, finishing and apparel-making firms and enterprises. Gujarat is one of the leading industrial states in India, and textile industry in particular has contributed in a big way to the industrialization of the state. Processes of textile manufacturing. Textile manufacturing begins with the production or harvesting of raw fiber. Fiber used in textiles can be harvested from natural resources or manufactured from regenerative cellulose materials, or it can be entirely synthetic. After the raw natural or manufactured fibers are shipped from the farm or the chemical plant, they pass through 4 main stages of processing: yarn production, fabric production, wet processing, and garment manufacturing. Fabric processing or wet processing. The fabric produced from the weaving or knitting is in rough condition and is often termed grey fabric. The material is rough to the touch and contains impurities which are either natural in the fibers or added to facilitate the process of fabric manufacture. Fabric processing or wet processing is done to improve the appearance and serviceability of the fabric in many ways. The main operations carried out in this step include pre-treatment, dyeing, printing and finishing. The pre-treatment process is carried out to prepare the textile material for subsequent processing, which includes dyeing, printing and finishing. The main operations include desizing. In this process, the sizing ingredients are removed from the grey fabric by dissolving them. Desizing with acid or enzymes, etc., then removes size from the fabric so that chemical penetration of the fabric in later stages is not inhibited. The scouring process is carried out to remove impurities such as wax, fatty acids, oils, etc. present in the fabric. Scouring is carried out in alkaline conditions with sodium hydroxide under high pressure and temperature above 100 degrees Celsius. Bleaching is used to whiten fabrics and yarns. Different chemicals such as hypochlorites, hydrogen peroxides, etc. are used as bleaching agents. The process conditions during bleaching vary with the type of agent used. Once bleaching is complete, the bleaching agent must be completely removed, either by thorough washing or through the use of enzymes. Mercerizing increases the tensile strength, luster, and dye uptake of the cotton fabric or yarn. In this process, the cotton yarn or fabric is treated with cold sodium hydroxide solution. This causes swelling of the fiber, which results in an increase in the dye intake. Excess sodium hydroxide is normally recovered for reuse in either the scouring or other mercerization stages. Dyeing is employed to give an all-over shade to the fabric. It basically involves diffusion of dye molecules into the textile fabric, which imparts the required color. In the dyeing process, these dye particles quickly come into contact with the surface of each fiber, form a thin layer and diffuse into it. Printing is a process by which colored patterns are produced on the fabric. Unlike dyeing, it is usually only carried out on prepared fabric where it is applied to specific areas to achieve a planned design. The color is applied to the fabric and then treated with steam, heat or chemicals to fix the color on the fabric. The most commonly used printing techniques are 1. Direct printing, 2. Resist printing, 3. Discharge printing, 4. Over-dyed printing. Finishing. This stage includes the final operations necessary for making the textile presentable and attractive. It imparts the final aesthetic, chemical and mechanical properties to the fabric as per the end-use requirements. The finishing operations include drying. Drying removes the moisture from the fabric using the drying machine, providing dimensional stability. This is one of the most important finishing operations. The fabric, which is in a distorted condition, is brought to the required dimensions of width and length. Calendering. A kind of glossy skin is formed on the fabric surface during calendering. The damp fabric is pressed hard against a hot, polished metal surface until it dries. The fabric is led through the softening machine so that it touches the studded rollers lightly and drags them around. In this way, the surface of the fabric is lightly disturbed, making it much softer. Environmental impact of the textile industry. Textile processing industry is characterized not only by the large volume of water required for various unit operations, but also by the variety of chemicals used for various processes. Textile processing generates many waste streams, including liquid, gaseous, and solid wastes, some of which may be hazardous. Water pollution. The textile industry uses high volumes of water throughout its operations, from the washing of fibers to bleaching, dyeing, and washing of finished products. On an average, approximately 200 liters of water are required to produce 1 kg of textiles. The large volumes of wastewater generated also contain a wide variety of chemicals used throughout processing. These can cause damage if not properly treated before discharge to the environment. Of all the steps involved in textile processing, wet processing creates the highest volume of wastewater. Solid waste pollution. The primary residual wastes generated from the textile industry are non-hazardous. These include scraps of fabric and yarn, off-specification yarn, and fabric and packaging waste. The textile industry is facing a problem of high uses of water throughout its operations, from the washing of fibers to bleaching, dyeing, and washing of finished products. It generates large amount of wastewater. It is suggested to implement water recycling system in jet dyeing and printing operation. In the jet dyeing machine, they saved 1,200 liters of water per lot. In a day cycle, from each jet dyeing machine, 4 lots are processed. Therefore, in one jet dyeing machine, 1,200 liters of water is saved. Thus, from 11 jet dyeing machines, 52,800 liters per day water is saved. Recycling and reuse of water in printing machine. One printing machine requires 1,500 liters per hour for continuous cleaning of the blanket. Therefore, in 24 hours, it requires 36,000 liters of water. The ETP plant water is filtered and recycled for its use in cleaning process. Therefore, the amount of recycled water used in 7 machines is 2,52,000 liters per day. Benefits. Total amount of fresh water saved 3,04,800 liters. Annual saving rupees 5,56,260. It reduces the huge consumption of fresh water. It also reduces the energy consumption.
मेरा नाम मनमोहन गर्ग, मेरा 20 साल से करीब ये प्रोसेस हाउस चला रहे हैं, रिंकू प्रोसेसर्स प्राइवेट लिमिटेड के नाम से। करीब करीब सब कपड़ा हम प्रोसेस करते हैं। कॉटन है, पॉलिएस्टर है, ब्लेंड है, वाइडर की बेडशीट भी बनाते हैं। करीब 90 से हमने प्रोसेस हाउस स्टार्ट किया है और अभी कुछ टाइम से जीसीपीसी वाले से मिले और उन्होंने काफ़ी सुधारा कराया सेविंग के लिए। और हमारे यहाँ जो टेक्निकल डायरेक्टर हैं राज गर्ग के साथ इनको मिलाया, इन्होंने काफ़ी चेंजेस किया है और काफ़ी हमको फ़ायदा भी हुआ है इसमें।
My name is Mr. Raj Garg and I am the director of Rinku Process Limited since last 10 years. We are working with the Gujarat Cleaner Production Center for the implementation project in textile sector. Gujarat Cleaner Production Center suggested several cleaner production options based on the feasibility study. We have implemented some of the suggestions recommended by them, which is converted in energy and water conservation. First of all, we have implemented reuse system in jet dyeing process, in which the whole cooling water is been collected in a water tank and is been taken to the boiler for making steam. Recently, we are using biomass in the form of sawdust instead of lignite or coal for making steam and for temperature, and this is also eligible for CDM projects. So we also started CDM project for the same. As per guidelines of GCPC and energy audit report, we are planning to install inverters on trial basis. Now we have found that some saving is observed, and we would like to install inverters on all machines, and for that we will be going to receive subsidy from Industrial Commissioner, and we are going to apply for that. We are very thankful to GCPC for suggesting such kind of savings. We are also planning to install metal halide lamps in our plant and office building instead of using tube lights, and technically it is proven that it saves 40% of electrical energy.
Textile industries are using varieties of machines in their different operations. It is observed that some of the machines are using more power than actual requirement. It was suggested to install inverters on all machines to control the power variations. Inverter is a device which maintains load of the equipment so that the machine operates on a defined load. It is proven that the inverter saves up to 20% of power cost. Total 44 inverters were installed on different machines in one of the textile units. Thus, there was a total ampere reduction of 397.4, which resulted in the savings of 4,450.88 kilowatt hour per day, resulting in the annual savings of rupees 73,43,952, which is a huge power saving for the industry.
मेरा नाम ललित मोहन चमड़िया, मैनेजिंग डायरेक्टर चमड़िया फैशन प्राइवेट लिमिटेड, नारोल, अहमदाबाद। हमारे यहाँ GCPC गुजरात क्लीनर प्रोडक्शन सेंटर की टीम कुछ टाइम से फैक्ट्री में आई। प्रोडक्शन को कैसे अच्छे ढंग से एनर्जी सेविंग में क्लीनर प्रोडक्शन कैसे लें, उसके लिए उन्होंने हमें गाइड किया। उनकी बातों को ध्यान में रखते हुए हमने अपने प्रोडक्शन यूनिट में कुछ पॉइंट्स को एग्जीक्यूट किया, जिससे हमें काफ़ी फ़ायदे हुए हैं। जिनमें फ़ायदे के अंदर डाइंग जो हम करते हैं उसमें उन्होंने हमें कोल्ड पैड बैचिंग डाइंग सिस्टम बताया था, जो हमने एग्जीक्यूट किया। तो उससे हमारी एनर्जी सेविंग हुई, क्योंकि ये जो डाइंग है वो कोल्ड ही डाइंग हो जाती है, और डाइंग होने के बाद जैसे सिर्फ वाटर सेविंग भी काफ़ी हो गया, क्योंकि उसको सिर्फ धुलाई करके ही डाइंग क्लियर हो जाती है। उससे जैसे हम पहले कंटिन्यूस जिगर में डाइंग करते थे तो उसमें स्टीम की भी कंजम्पशन ज़्यादा थी और वाटर की कंजम्पशन भी ज़्यादा थी, और कोल्ड पैड करने से दोनों पॉइंट पर